This lecture is on the ideal gas law for problems involving both molar mass and density. The ideal gas law is one where one can study moles, temperature, volume, or pressure of a gaseous substance using this equation. PV equals nRT, where R equals 0.0821 atm/L per mole K, or 62.4 mmHg/L per mole K. Molar mass is defined as the mass of a substance per 1 mole of substance. Using the ideal gas law, if one knows the mass of the gas, the moles of the gas can be solved by the ideal gas law. It is N equals PV divided by RT. From there, take mass and divide by moles to get molar mass. Overall, molar mass can be calculated by this equation, MM equals MRT divided by PV. Density is the mass of a substance divided by its corresponding volume. For gases, the units are grams per liter. From the ideal gas law, calculating the density of a substance can be done by the following equation if grams of the substance is given. V equals nRT divided by P. Alternatively, density of a substance can be determined by the following equation from the ideal gas law. D equals P times mm divided by RT. If the substance is measured in SCP, where P equals 1 atm and T equals 273 K, the molar volume of the gas in SCP is 22.4 liters per mole, and therefore D equals mm divided by mv. Let's look at some problems. Problem 1 is 6.30 mg of a boron hydride compound is contained in a flask of 385 ml at 25 C and a pressure of 11 torr. A, determine the molar mass of the hydride, and B, which of the following hydrates is contained in the flask, BH3, B2H6, or B4H10. It is given that M is 6.30 mg, which equals 6.30 times 10 to the minus 3 grams. V equals 385 ml, or 0.385 L. T equals 25 Celsius units, and P equals 11 torr, or 11 mmHg. One needs the ideal gas law for the equation of molar mass, where mm equals mRT divided by PV, where R equals 0.0821 atm/L divided by mole K, or 62.4 mmHg/L per mole K, and the temperature equation converting Celsius units to Kelvin units. The solution map is to take the temperature in Celsius units and convert to temperature in Kelvin units. Then, with V, P, R, and T, use the ideal gas law to solve for molar mass, and from the value obtained, determine the identity of the gas. The temperature is 298.15 Kelvin units, and therefore, after plugging in the values, the molar mass is 27.7 G per mole. The identity of the gas is B2H6. Problem 2 is calculate the density in G per L of 478 ml of krypton at T equals 47 C and P equals 671 mmHg and B at STP. For part A, it is given that T equals 47 Celsius units, P equals 671 mmHg, and mm of Kr equals 82.80 G per mole Kr. One needs the ideal gas law equation for density, where D equals mm times P divided by RT, where R equals 0.0821 atm/L divided by mole K, or 62.4 mmHg/L per mole K, and the temperature equation converting Celsius units to Kelvin units. The map is to first convert the temperature from Celsius to Kelvin units, followed by using P, mm of Kr, and R. Use the ideal gas law to solve for density. First, the temperature in Kelvin units is 320.15 K. After plugging in the values in the density equation, density is 2.82 G per L. For part B, it is given that T is 273 Kelvin units, P is 760 mmHg, mm of Kr equals 82.80 G per mole Kr, and molar volume is 22.4 liters per mole. One needs the ideal gas law equation for density, where D equals mm times P divided by RT, where R equals 0.0821 ATML divided by mole K, or 62.4 mmHgl per mole K, and the temperature equation converting Celsius units to Kelvin units. The map is to first take the given TPR and molar mass of Kr, and then using the ideal gas law or molar volume, solve for density. After plugging in the values in the density equation, density is 3.74 G per L. Alternatively, if you take the molar mass of Kr and divide by the molar volume Kr, it equals 83.80 G per mole, and divide by 22.4 L per mole, it also equals 3.74 G per L. Here are some review exercise problems for you to work on. Solve each of the following exercises. A, calculate the density of SF6 at STP. B, 0.30 G of a gas occupies a volume of 82 ml at 3 atm pressure, and 27 C. Calculate the molar mass of the gas. C, a sample of gas has a mass of 2.929 G, occupies a volume of 426 ml at 0 C, and 1 atm pressure. What is the molecular weight of the gas? D, an unknown gas has a density of 3.167 G per L at SCP. What is the identity of the gas? Your choices are AR, O2, Cl2, HF, or H2O. For the remaining part of this lecture are solutions to review exercises or problems. Please view only after completing these exercises.